Doo-be-doo-be-doo. Doo-be-doo-be-doo-be-doo. Doo-be-doo-be-doo-be-doo-be-doo. Doo-be-doo. Ah, we have sound, we have sound. Cool. Welcome, welcome, welcome. Yeah, I'm back. Read and write data files, huh? This could present an interesting day. So, data files. Reading and writing data to a hard drive or SSD, whatever you want to call it. Interesting stuff. A bit problematic because we're going to be dealing with a physical device, and physical devices can fail. We could even upset them. We could make them fail. We have to be careful what we're doing, I think. So, that's going to be interesting. I wonder how Rust deals with that. Right, well, we're going to need a project. What shall we call it? Data files, I guess. Yeah, data files. So, here we go. Oh, this is going to be fun. Reading and writing to a hard drive isn't as straightforward as people think. No matter what language you're using, whether it makes it easy or hard is up to the language that you're programming in. But at the end of the day, the effect is the same. You have to be careful. I'll give you a basic reason. Let's set up a project. Data files, huh? Alright, so cargo, new, data files, and this is going to be a dev. It's going to be a sandbox in which we can play around and have a little bit of fun, see what happens. There we go, data files dev. Ba 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 ba. Yeah, the reason to be aware of what's going on with this kind of thing. If you've got an SSD, it has a lifetime. The amount of read and writes you can do to an SSD is limited. It's a lot of read and writes you can do. They are structured in such a way that if an area goes out of use, then it gets put to one side and isn't used. So there is software on your SSD which helps extend its lifetime. At the same time, you're not really out to kill it, are you? So unwanted read and writes are to be avoided. That's the first thing. I don't think people realise it, but yeah, it's true. We'll need a file, won't we? New file. README. We'll have our standard README. Okay. In here, we'll have the Rust language. Forgot how to spell it. Homepage. So we'll take that as our first reference. We're not going to be using a crate, not after last week's little experimentation with crates. I found out that not everything is as I expected. I thought that the crates for Rust by this stage would be better written. I've had a look at Bevy, which is, or seems to be, the most popular of all the crates for game programming. And it's not right, shall we say. I'm going to be polite. It's not right. It's far from right. I'm able to produce errors from that code quite easily, far too easily. When I was looking into it, they've known about it for years and haven't done anything about it. Okay, what we're going to be using today, the standard library. Get started. Alright. Install. Oh god. Read the cargo book. Okay, yeah. Right. Is it me? No. There's a learn button here. Here we go. Documentation. Here we go. The standard library. Okay, let's have that. I think that might be a good place to be, because we're not using crates. This is an index. Okay. So, the standard library. Most languages have one. And it's full of stuff. Stuff that you can learn, should you want to. There we go, standard. Crate, STD. Great abbreviation. They really didn't think about it, did they? Why don't they just call it standard library? I don't know. Okay. This just seems to be some kind of main menu. Okay. Alright. It's got all this stuff on it. What about the modules? Here we go, modules. Ah, right. Awesome stuff. Right. So in the standard library we have all of these modules which are here to help us out. File system manipulation operations might come in useful. Okay. Here's our main. Let's run it. And it does that. Hello world. Not really what I want, but hey ho. So let's just get this altered. Welcome. Yeah. Welcome to data files development. I'll put some extra lines in. Yeah, I'm happy with that. I think we're okay with that. Okay. Yep, welcome to data files development. Fantastic. So that's your starter for 10 that we get from starting up a new project. Data files development. So, what we need is a goal, I think. Some kind of goal. So, let's keep that simple. So we need to, what? Find a place to store our data. What else can we do with this? Save and load, read and write. Write our data to disk. We'll call it a disk. Yeah, something like that I think is probably good. Write our data to disk, and read the data back for use. By an app. I think, yeah, application. Let's slow down on the abbreviation, shall we? And start putting real words in. Abbreviations can be interpreted badly, so sometimes it's not a good idea to use them. So, as usual, we're going to use our main.rs as a fake application. So this is going to do all the operations. Does mean we're going to probably need a different file. So we can do that. That's our basic setup, isn't it? I'm trying to think how far into this I want to go before I do a basic setup. I think we're at it. Alright. So let's set up our base setup. Let's take it at that point. There we go. Base setup complete. Everything's hunky-dory. Which means we can get rid of that now. Lovely. Things are looking good. That was easy. A lot easier than I found it last time, which is good. No idea why it keeps putting this thing up. Cargo reference profiles. Alright, that guides me to some kind of reference material. Okay, that's fine. I don't really appreciate it. Can we get rid of that? Alright, just just leave it lying around at the bottom, I think. Alright. Lovely. What are we going to need? Data files. Okay, let's pop that in first. Let's start getting this thing structured. Yeah, just call it data files. We can do that. We can do that. Create module at data files. Done. There we go. There's our data files reference now. That's good news. So we've now got 2 files. What we're going to need. So the best way to program is usually by writing out what you're going to need. So let's have test data. No, I don't like that. Data for testing? I don't know. It's going to be a structure. So let's have a data structure. For test purposes. I think that's probably going to be the best idea there. Now in our main, don't really want anything, do we? Not yet anyway. Let's have a look at our data files. Where are we going to store them? Where are we going to put our data files? On the hard drive, disk, whatever you want to call it. Where are they going to go? Are they going to go in source? Are they going to go in target? Are they going to go in the main directory? There's options, isn't there? So we're going to have to create a directory for our data. We don't know where that's going to be. If it does not exist, I think that's the best way of putting it, because you can't create a directory that already exists, can you? So let's be fair on that one. We'll want a way to save our data, write our data, save. I'm going to call it save. Then it's not going to conflict with all the read and write functions in here. So yeah, save our data in a text file. What are we going to call it? Let's call it config. In config.text, read our data from, so that's load, load our data from config.text. We're going to need something else, aren't we? These are text files. So text files are full of strings. Well, that's not true, but it's the best way of looking at it. The truth of the matter is text files are not full of strings. they can be full of other things as well. So we need to be able to distinguish between what our strings are and what is inside the string. So we need to be able to look inside. We need some kind of string manipulation. So, yeah, we are going to need serialize. I'm English, so I'll put an S. And deserialization of strings. What that means, to serialize something means put it in a string. Deserialization means take it out of a string. It's just technical words designed to confuse you. They do a good job with me. Confusing me isn't difficult. So they use big words so that I get confused. I like that idea. Confusion and me get along quite well. You can get crates for that. We could get a crate that does that for us. Why should we want to after the experience that we've had so far? We can do it ourselves. It's not a difficult concept. I don't know why people would want to get a crate for it. Maybe because it's big words and it confuses us. Good. That's probably why they get a crate for it. Now, is there anything else we're going to need? Probably. That's going to be a mod. So we can do the first one. I think that one we can do straight away. So we're now starting to see a structure to our program. It's starting to take on its own little life, as all programs often do. They take on a life of their own and, well, get messy. I'm just seeing if there's anything else in the back of my mind that's going to say, hey, stop, wait a minute. Alright, so I think that one's okay. What we're going to do about this? You see, we don't know what our data is, do we? And I think that's what it all comes down to. What is our data? I think I will have a module for that though. We'll just call it serialize. Oh, that seems to be taken. No, it's not taking it. It's just taking it out the words that I've already placed in, isn't it? Huh. file. Fantastic. So that's set up. Shall we just have a look at create a directory first of all? And then start deciding on other things as we go. So where are we going to save our data? We don't need to know what our data is for that. That's fine. We can make a public function for that. Yeah. Yes, public functions for saving data into. That's a good idea. Create a directory for our... Yeah, okay. So we're looking probably at public function. We're going to call it... what? Check. Data directory. I guess. There you go. Done. And that's going to be our first thing. Data files. Okay. So, no, I'm not going to put notes in at this point. I don't think I'm ready for it. So, let's have a look at this. We're going to be in data files. So that. Check directory. There we go. All done. That was simple. That's going to be the first thing that we do. Now we're looking at physical devices. Error checking. Physical devices could be faulty or not even there. Yeah. Okay. Okay, there's another goal here. No, do that. Think about error checking. Something I wanted to do last week. Didn't really get around to it. Didn't have time. But I think in this little development environment, it might be a better area for looking at error checking. That could be important. We can call our create a directory. That's going to be a data directory because we're going to call it data, I guess. So we can put that in. We've got our first thing already. So let data directory equal data. Is that fair? Are we allowed to do that? Yes, we are. Nice language. I like this language. It does it for me. Things are done for me. Lovely. What else will we need to know? We'll need to know whether it exists or not, won't we? So I'm doing this a bit of a naive way and just thinking my way through it rather than having a plan and saying this is how we do it, because yeah, this is a different language to me and it acts differently, which is good. I'm going to have sorry, no, we'll just call it directory exists. Directory, which it doesn't obviously, but exists equals false. That's our starting condition, because it doesn't exist, does it? Alright. Can we ask our hard drive to check that it doesn't exist? Does the directory exist? Yeah. If no... directory, then create one. Create it. I think that's about... that's very bad English, isn't it? Create missing directories. That's better. Yeah, we can put it in 3 words. Create missing directory. Yeah, okay. We don't need to return a value. Okay. File system. FS. File system manipulation operations. Let's have a look. See what we've got here. Permissions. Functions. Create directory, that's useful. Exists. Returns OK true if the path points at an existing entity. Oh. Wonder why they've used that language. We've got read, we've got set, we've got write. That's useful. Let's have a look at exists. Use standard FS. Oh, okay. I like this manual. It gives us a true return result. It can also give an error, because that says OK, so that means it's true or an error. Yeah, error. Path exists. Yeah. Yeah. Now I don't know where it's going to exist. I've got no idea. Does that matter? Let's ignore that for a second. Colon. We're just going to have FS, aren't we? FS. Semicolon, I guess. Okay. So I'm just going to see how we can just type in fs : exists with an expect. That'll crash the program if it doesn't exist. So we don't want that. So what we're looking at here is directory exists is going to equal fs : exists. It needs a path. I'm just going to throw in the data directory, and we will store the result back there. There's a question mark on that. I'm going to ignore that. We set it to bool. I don't think this variable's needed. Okay. So at this point, that value has now been set to whatever this returns. IO result bool. Okay, so it is going to give us a bool back. Returns OK true if the path points to an existing. OK false. I don't like this. This doesn't make sense now. That line doesn't make sense anymore. You see, we've got a result bool error. Can you see how that's different to being just a bool? In this language, we don't necessarily get the type of thing that we're looking for. So it's OK false. That's confusing with this. As opposed to path exists. This will only return OK true or OK false if the path was verified to exist or not exist. Ugh. If its existence, who wrote this? If its existence can neither be confirmed nor denied, an error. Ah, that's what the error is. So we're not interested in errors. I see. The error isn't what I thought it was. Alright. So I do want that. So that is a .expect. We're going to actually handle it with a message. That is going to be error accessing your hard drive. I think because that's what it means. That's what the error would be. It would be an access error. It wouldn't be that the directory doesn't exist. Doesn't like that, does it? Huh. Can we just get rid of this a minute? Interesting. So why wouldn't you like that? Immutable variable directory. I get you. Alright, we're back to that, are we? Alright, thank you. So we need to be able to make this mutable so we can assign it a value and overwrite the false. Yeah. Okay, so we now know that this is true or false because we've read the manual. Oh my god, having to read manuals at my age. So, if directory exists is equal to false, then we're going to do something, aren't we? Okay. Why is this still underlined? Value assigned to directory exists is never read. Maybe it is overwritten before being read. Unused assignment. So it doesn't want that. Okay. We'll just do that then. Variable does not need to be mutable. That's interesting. It told me here that it did. So who's correct? I don't think this is the right way to write Rust. It isn't, is it? By putting that expect in, we've taken away the error value and we've only got a bool back. That's brilliant. This works. That works better. Huh. You see, I'm learning to write Rust at the same time as looking at this standard library. That's an interesting way of doing things. I'm not used to that. I'm used to setting up my variables and then using them. In Rust, it seems as though we don't do that. Okay. Can I just put a return on that so I can get it on screen? The error is taken this way, the bool is sent back. Nice. That's pretty good, that. Right, so can we make a directory? Function create directory. It's got a result again because it's got this error. Create a directory, what comes back? Errors. Oh god. What does the error mean? It returns an error in the following situations, but is not limited to just these cases. User lacks permissions. A parent of the given path doesn't exist. Path already exists. Interesting. Okay. Let's keep this simple. I'm thinking about that because that means that this covers that case. This function actually covers this. That's a bit weird. Why do functions? Hello, we've got shading. How am I finding Rust? It's brill. You've been meaning to learn it for a bit. I think it's advisable because you're forced into doing things differently, as I'm finding as we're going through this. I wouldn't do things like this normally, but I like the way it's doing it. The language, it guides you very well. I'm very impressed with the way it's doing things, and the way it's structuring the programs is actually awesome. It's definitely a journey. I'm definitely going to call it a journey. Did I have any coffee left? So we're going to create our directory. Remember, I don't know what's going on here. I have got no idea what it's going to do to me. I'm going to let the language... Oh, we need our path again. So that's data directory. Okay. This can result in an error. So I'm going to put another expect in, because if we do get an error, I want to crash the program. The message would be error creating the directory. I'm trying to make this as generic as possible as usual. We're just going to pop you down here for a sec. That's done. What happens if we run that? Fair few things seem to be being written, refactored into it recently. I'm not too worried about a language changing or being developed as I go. What I worry about usually is a language that isn't being developed. So, quite happy for them to do things. Do we think what I've written will work? Well, according to Rust, if you write something and it doesn't give you squiggly lines everywhere, it should work. Let's run it and find out. I'm going to keep this open because I don't know where data is going to go. Remember, we've got a choice here. It could go in the main area. It could go in our source files. It could go in to data files. It could go even into target in here. This is one of the beautiful things about writing this kind of program. Don't try and force it. Ask it. Let's run it and find out. We have a data directory. It went onto the top level. Now that makes sense because that means that the top level here is the current working directory for the project. We didn't specify, you know, put it anywhere else. You can do. We could have put /.src. So we could have done that and put it into our source directory. So now I know where it basically goes. It goes into the current working directory for the project. I could now guide it to wherever I wanted to. So this simple experiment has proven wise. If we run it again, it shouldn't go through create missing directory. How could we prove that? Don't need to prove it. I know it doesn't go through there. So we're not doing things that we don't need to prove. So this will now get missed. Does the directory exist? Yeah. That'll become true. It won't do this part, and it just returns back doing nothing. That's really cool. So it just checks. That check. Okay, that was actually quite straightforward. Now we need to save our data. But we don't know what our data's going to be. Okay. So here we can write in checking ching. Checking that the data directory exists. I think we'll come up with a simple solution there. We'll keep it. We'll keep that. Okay. Could we make this any better? Yes, we can. We can combine these two into one operation. But I think what I've done is more explicit, so I'm going to leave that alone for a second. And I've got to stop the capitalizations of things. Alright, do we give ourselves some data? Will that be distracting? Yeah, that will be distracting. There's a few things to worry about here. Save our data in config.txt. How? Let's take the naive approach then. We'll use a public function. We're going to call this save data. And this is where the problems really start. We're going to have to pass our data in to this function. How? This is the biggest problem. This one, I'm going to call it a variable. What we would have to do in a main program or an application is gather all our data together. So we'd have gathered data. Okay, so let's get that sorted out. So it's just going to be a structure of some kind. So we'd gather our data together into one place. And then we would try and send that gathered data into our save data. What could we call it here? All data. That would be of type gathered data. I see, you don't do that. Right, well you have to do this slightly differently, don't we? Okay, we'd do it something like that. Right, it doesn't know what gathered data is. Alright, we'll just pop an import in for that. I'm not sure I like that idea. Use variable all data, blah blah blah, unused variables on by default. Okay, yeah, unused. Right, okay. So back in main RS, we could data files, save data, and that would be gathered data. Now we're not looking to change our data in any way, so I don't want it to be mutable, but I don't want it to be copying our data either. So this needs to be a reference, a pointer to our data. Otherwise it's going to copy all of our data into here, and then at the end of it it's going to destroy it all. Yeah, let's just have a pointer, shall we, so that doesn't happen. That's the first consideration. Don't destroy your data when you're saving it out. Not a good idea. Your main application may still require the data. Yeah. So that's what that little symbol means. And it's why we use pointers and borrowing and things like that, which this language is brilliant at, because it stops us destroying things and making a mess. Alright, so we can save our data. Okay. That's fine. Do we need to return anything? No, we just want to save it out and that's it. Fine. So we have a simple signature for what is a very complicated function. I'm going to leave a space for variables because I don't know. I always like to do that. Check data in case we need to serialize. Because we don't know what our data is. It could be a string. If it's a string, then that's fine. We don't need to serialize it. We can just send it straight out. This is going to be a loop. Loop through our data. Okay. Which means we have one of those. And one of those. Don't know what type of loop I want to use. So check the data, check this item of data in case we need to serialize. And then we can just save the data. Save this item to file. So we do need a variable. We do need as soon as I've done that, I know I need a variable. So I'm going to put it in so I know that I need it. So data file. We're going to make that equal to, what did we want to call it? Config text. Is it though? It isn't, is it? It's data config dot text. There we go. We have to put the path in because otherwise it'll try and save it to the top directory and we want it in our data. So we're going to ask it to put it in our data. Interesting. Open the file for write access or any kind of access. So not necessarily write access. Okay. Because I don't know whether we can do that. We'll find out. Blah, 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 blah. Loop through our data, check if we need to serialize. Yeah, loop, blah, blah, yeah, open, yeah, okay. That sounds reasonable. I always put a close in. Close file as we have finished. Okay. That is the basic structure of how you would save out a file. According to theory. Open the file for access. Okay. It's going to be part of FS, isn't it? I think it is. Or is it part of I/O? Is there an I/O? There is. Traits, helpers and type definitions for core input output functionality. Let me just have a quick look in here. It's still using FS file. We have a buffer. This looks awful. I think I like the idea of a buffer. We'll come back to that. We don't. This is save. That's read. Forget it. We're writing. We already have it buffered. Or we will have it buffered here in the serialization. We've got strings. Strings are actually buffers. Anyway, it's irrelevant. Alright. Just having a quick look through these. That's a reader, writer. Oh, we could set up a buffer and then write the buffer. Oh, you little beaut. Now, at the beginning of this, I said the number of read and writes we do to the disk is important. This has just highlighted it in my mind again. The more read and writes we do, the more we decrease the lifetime of our hard drive device. Yeah. So we only really want to be writing to it once, and that's why it's buffered. I like this idea. I'm not sure how it's going to be used though. But this comes under input output, and we've got an FS file. We're using a writer, write, yeah. The buffer is flushed once writer goes out of scope. Oh. Well, that buggers it up. Because anytime you have a buffer, you've got to make sure that the last operation you do on that buffer before closing the file here is that everything gets sent to the file, which we call flushing, as you would with a toilet. You empty it. Ah, I can see that wouldn't. Yeah. What I want to do is change this to say add this item to the buffer. But we don't know how much data we've got, so how big would the buffer have to be? If it writes the file, it doesn't have to re-access the file, therefore it doesn't matter. This wouldn't... does this create a stream? If it creates a stream, it doesn't matter. When writing to a file, you can stream data into a file. And that saves on extra read and writes. Or extra accesses to the hard drive. It doesn't tell us. Just buffers every year, okay. Okay. So I was right to look at that. That's module IO. Let's go back to the file system. And we're looking under writing. Writes a slice as the entire contents of a file. Oh. This function will create a file if it does not exist and will entirely replace its contents if it does. Ugh. That means we can't use a loop. Otherwise, every time we go through the loop, it just creates a new file. It's convenience function for using create file and write all with fewer imports. Yeah, okay. That's not exactly what I expected it to be. I think I'm starting to see how this isn't structured the way I thought it was. So all of the implementations for write aren't under write. Write is just convenience for a quick file write. Okay. That's a little bit annoying. Let's go back to IO. So it's got all of this stuff, has it? That's lovely. Iterators. Ah, it's got iterators. That's good news. Result. Safety. Yeah, I understand the safety aspect of all of this. Thank you. So we've got buffer reader, buffer writer. Can you see the problems with doing file operations now? Line writer. Lines. This is more like it. Okay. Read to string. Oh, we might need that later. This is interesting. Flushing whenever a new line is detected. Line writer. Well, just opening a file. I'm a little bit dubious about this. You see, if you open a file, you can read and write to it. Oh. That's not exactly what I want to do. I prefer it to be a bit more restrictive than that. We've got create. There's different ways of doing this. Okay. Utilities for formatting and printing strings. That might be useful. I'm seeing things that could be useful. I'm not seeing anything that's jumping out and saying, hey, come and use me. File. An object providing access to an open file on file systems. That sounds interesting. Let's have a quick look at you. File open. Yeah, it's looking like we just got file open. I'm not happy with that idea, but let's current file equal it'll be fs. I'm guessing yes it is. It's fs file open. Blah 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 options blah 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 set sync bytes. Oh, we could use bytes. Oh, lovely. There we go. Read. Right. Write all, write format, write vectored. There we go, there is a write function. Result is a use size and an error. A use size I accept, that's just a file handle. That's fine. And the buffer is U8. That's strings. Oh, U8s, yeah. Writes a buffer into this writer, returning how many bytes were written. Writes a buffer into this writer. Mute self. Self is write. This function will attempt to write the entire contents of a buffer. Oh! That's nice. Calls to write are not guaranteed to block waiting for data to be written. Okay. And a write which would otherwise block can be indicated through an error variant. Okay. If method consumed, blah blah blah. Do you create a new file? Errors, examples. I like the way they've given an example that doesn't include this. Okay. Don't like it. Sorry. Don't think that suits our needs, so it is going to be open, isn't it? Okay, yep, that takes a path. That's going to be our data file. Okay. I've got an open file. I'm going to skip that bit and go to that bit. Not sure how we're going to loop through our data. That's going to be an interesting one. Save this file, save this item to a file. Okay. So data, our final. No, it's going to be line. What are we going to call it? Data current. It's going to equal. We're just going to make it into a string for a minute. Okay. So we want to save that to the current file. Current file. Expect is errors, it's a maps, okays, unwraps. Oh, there's nothing. So it's probably going to come under something else. Does it come under our current data? To string, to socket. Oh, we can send it to a socket. That's nice. All right. Keeps using this buffer reader. We can act on the file itself. I thought it was. Yeah, we have to access that. Current file. but there's nothing here. I'm suspicious. I'm very suspicious. Right line macros. We have write using the standard file system. I'm going to go with right line. What do you actually do? Doesn't tell us. Ah. Okay. Path contents. Writes a slice as the entire contents of a file. Yeah, we've seen this before, haven't we? Then it's write underscore all. Oh. Got write data, write bytes. What's the difference between write bytes and write data? Write via move. Blah blah blah, volatile, unaligned, blah blah. Why are you giving me this rubbish? I don't want bytes. So from what I've seen so far, it's not clear. They're seeming to use buffers. I know why they use a buffer. It's probably wise to do so. So you'd open a file, then you can assign it a buffer. All right, let's go with it. Okay, let's go with that. This is going to be buffer writer. Yeah, we'll do that. We're going to need a standard I/O thingy. Yeah, we are going to need a standard I/O. Yeah, you actually tried. I see. Can we just get rid of all of this garbage that you've given us, please? I don't know why it gives me all that garbage, but it seems to like to do so. Fine. We don't want that. So this is gonna have to be IO, buffer writer, we'll want a new, and that's going to have a file, so that's going to be our current file. Okay, like that. Okay. So we're going to assume at this point that we have a set of data that's coming back called test from our serialization or deserialization or whatever messing around we do with it. How do we save this item to file? It doesn't like that. A trait is not satisfied. Wraps a writer and buffers its output. Yeah, okay. What do you mean a trait is not? It is a stream. Bollocks. Thought it would be. Love it. And you're going to TCPs, are you? Oh, I see. This is opening a file, isn't it? Oh no. Is not implemented for result file. Standard IO error. Is it not now? I've got a feeling that that's TCP. That's internet. Bollocks. Okay. That's not going to work. Trying to read your name. Is it Silen or Siphon? I can't read that properly. Open options, controls, read, write, access. You didn't handle error that can happen when opening the file. Good point. I think I understand what you just said. Ha. Ah. Can't open file for save. We'll pop you in. See if you make a difference. I get you. So if you don't handle the error, it passes the error on through current file, which messes up the buffer writer so it can't handle the input of the current file. And now we've got a buffer writer to the file. That's clever. That's very clever. Oh, I like this. We'll just move you down a little bit. Oh wow. Sorry, I'm gobsmacked. I've never used a language that's done that before. Right, so it really wants you to handle the errors. I'm using .expect because it's easy. It's a very convenient way of using up the error value, but it does crash your program if the error happens. Be aware of that. We're not actually handling the error properly. Error handling is something I want to do more in depth. In fact, I might go through this and do full error handling on it, because there's plenty of them, aren't there? Wow. So how do we use a buffer writer? Write to file. You just place things in the buffer and it does it itself. Ugh. So we have to place in the buffer our data. And then save it to file. Oh my god. Yeah. Critical to call flush before it's dropped. Yeah, I understand all of that kind of thing about flushing. Yeah, if you're using large amounts of data, buffering is a very, very good idea. But how big's my buffer? Can you tell I'm not happy with what we're doing? Shall we try something a lot simpler than buffer writer? Because it's raising more questions than it's answering. Like, what is the size of the buffer? Do I need to iterate through my test data more than once to buffer it out to the file? You see, if our buffer is only 2 characters, we have to go through the save twice. We can only put TE into the buffer, save it out, and then ST into the buffer and save it out. Yeah. So this is correct, but you need to be able to control the size of the buffer. You can obviously do that. And if you don't set the size of your buffer correctly, yeah, weird things happen. Eight kilobytes for a default size, yeah. So I'm right, you can set it, yeah. I thought so. It's making sense. It's making sense. Yeah. But I'm also thinking there's let's just have a quick look at write a string to a file. Let's just hold on a minute and see what this little got it one moment comes up with. It comes up with the write all idea. Okay. So let's have a look at a practical guide. Writing to a file in Rust, blah blah blah. Write all. Okay. Write all. Error handling. See, they're using SERDI. Yeah. That's what I'm trying to avoid. We'll do our own. Again, using write all. Bit limited. Bit limited. Writing and appending data. I wasn't do we want to append? Interesting. Again, write all. Is this the only option we've got? File open options, yeah. Yeah, conclusion. Write all is being used everywhere. See what they're doing here is, let's just get rid of this for a second. In the simplest of cases, they're taking the data file and then they're writing to it, which, okay. That. and it's binary. That's what I want. All right, let's see what I've got in chat. Handle via the right tray, yeah. Yeah, the right macro. But how do we use that? This is interesting. Thing to write, yeah. Got you. Thank you. I'm looking for a simple variation. Can I find one? Let's try that. Because that's complex. Oh. See what you mean. So what this is saying is use the macro. You see, if you type different things in here, it's going to come up with different answers, and they're usually pretty damn basic. So like that, we would have our current file. And our data current. Good. Can only be used if the data, yeah, it's in scope, yeah. Uh-huh. I see. We can't use the macro out of scope. The scope is a use standard IO write. Hmm. Which doesn't seem to help. Current file needs to be mutable. Current data needs to be mutable, doesn't it? Yeah. What? For format? Interesting. Why does that need to be mutable? It doesn't, does it? Okay. So we've followed what it's told us to do, and that's what it's come up with. That'll work. We're not looping through our data yet, obviously. I'm dreading what's going to happen if we loop through our data. That's going to be interesting. Close file as we have finished. File gets closed automatically when it goes out of scope. Yes, it does. How do we know that everything's been written? There is a flush on any writers that's on there. I think that works. We're not using this yet. We haven't got that far. I love these development environments. I like what we're allowed to make up, because I've just made that up completely from no idea what I'm doing. And it makes sense. Fact, we're using a macro, and it doesn't tell us what the macro does, well, is, or the code behind it. This means we don't need serialization. What will that do? Data written to file. What are we using? Data / config.txt. Well, there is no config.txt. That's a good start. So let's mess around with that. See what happens. Oh! Use struct literal syntax instead. Huh. I'm gobsmacked. It matters? What's it after? Not a semicolon. I don't understand the error. Huh. All I was going to do is that. Something like that. Oh, I see. It wants me to put a value in. Huh. Oh, it doesn't like that. It's not doing what I expected to. Which is fine. I don't think it can handle what I'm doing because it... Yeah. It's not in use, is it? Oh. That's why. It's me being stupid. It's just me being stupid. Item 1. Why can't it recognise that? ToString. Pardon? Found str. Ah. Da 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 da. A built-in type with a similar name exists. str. Pardon? Is this confusing? And str instructs you. Okay. Yeah. Getcha. I'll go back to that for now. I'll just put ToString. Go with what it's saying. Test data should now exist. str is a string slice that points to a string stored elsewhere. Got you? That makes sense. It's functionality of the capital str. Expected and gathered data. Found gathered data. Okay, we can do that. Wow. We'll just tell it it's not being used for now. Oh, it didn't like that. Okay. We're going to have a warning. Sorry, I don't like warnings. Unused result. Let's say error. Writing to open file. Alright. Get rid of that one. I'm not too bothered about that one. We can do that and that, but it doesn't quite like it. Alright, so we won't. That's fine. This is awkward, but hey ho, it all works. Okay. I'm just going to run Clippy on it because I'm not overly confident in what I've written. It says we're okay. Okay, we did get an error though. Thread main error, can't open file for save because it doesn't exist. Ah, you see? That's fantastic, it worked. Can't open file for save. So we can't open. So we have to create. Okay. There we go. I'm impressed. We were able to do it. Just separate that line off. Okay. So that's the basics of it, is it? Let's try a loop. So, 4. For loop won't work. Oh yes, it will. I wonder. Let's not do that. Fire in. Don't like that. Let's do a while. Number. Items is less than 5. Anything will do. I'm doing a for loop but backwards. Let number of items. This is all testing out equal to 0. So we're just going to have number of items plus plus, aren't we? It's an I32. Why won't you like an I32? Immutable. Why doesn't he like plus plus? Plus equals 1. Okay. Strange language. There we go. So I'm going to run through that, what, 4 times? Five times. And that's what I suspected would happen. One of the things that we're going to have to do, it's current data plus \n. Okay. So that was our first test. Could not compile that. Yeah. It doesn't like a plus. Oh my god. Two owned. Wow. Really? Yeah, okay. I can understand it. No, maybe not. I don't think that's right. Okay. Data isn't mutable. Change right to right line. That's a good idea. Hadn't thought of that one. Didn't even know it existed. There we go. Alright. We get 5 tests. This is working. That's a nice easy way of doing it. What I was worried about was each time we came by here it would overwrite our first entry, but it's not. It's actually adding to the file. It's appending. I'm satisfied with what that's doing. Good. I think we've got a save data. A save data that is going to operate in a way that I expect it to operate. That's impressive. The error handling... oh god, excuse me. The error handling helped there a lot. It's also taught me something about error handling that I didn't expect. So the reverse must be true. Or is it? One of the interesting things with languages is that they might not reverse. I think I'm alright with that though. Okay. Test complete. So what we're looking at here is a public function. Let's save data, so let's have load data. It's not going to take anything in. It is going to have to return something or other. Probably a gathered data. Don't like it already. Yeah, you're gonna hate that. Yeah, we're not going to do that for a second. I'm just going to type in here loaded data. We'll just pop you in there, and that means we can pop you in there, because that's just a note. I think you're starting to see how I write code. I don't always ask it to do exactly what I want. I'll just leave notes around until I'm happy with what I'm doing. Yeah, you can write to-do pling. I've tried that in the past and all it does is crash. The to-do pling, the to-do macro, seems to exit your program by crashing. I'm trying to avoid crashing, even though these expecs will crash, as we've already seen. But these I expect to crash, ironically. And I don't mind those, because they actually give me a message. A to-do doesn't, well, it can do. A to-do, not overly happy with that. Not overly happy with the way it's handling things. So, yeah. It's there, it's in the language. If I learn how to use it properly, then yeah, I might alter the way I do this. I tend to use print line and stuff like, you know, very, very simplistic logging. Maybe we should write a logging system. There's an interesting idea. A proper logging system. I haven't learnt fully the language's logging system, so that might be a bad idea at this stage, because we'd probably just be reinventing the wheel. Never a great idea, is it? Right, so loading data. We do need to do error handling. It's a similar kind of idea. We didn't need that. I'll take that out. It's exactly a similar idea. We're going to have our variables, aren't we? What I want to do is try and match our save file. That's the first intention. So we're really looking at that line there. And I'm doing this on purpose. It's not the best way of doing it, by the way. That should be passed in to the here. So that goes in here eventually. This variable should be gotten rid of. All of these kind of things for the future. I think it's the same program. This time though, it is open. I'll keep that. I'll keep the loop. This is the wrong way round. That will be load. That will be read. We need to do that first. So we have to swap this around. Okay. So we do have a problem that we don't have a read line. We have a write line, but we don't have a read line. So this isn't correct. I'm gonna try current file. Let me, in other languages it would be current file dot read to string, yeah, buffer, some kind of string. So that would be data current. Got you. Yeah, and it's asking for a string, a mutable string. That makes sense, we can do that. Yeah, that's that read line. It can fail. So I'll just cut you off there. We'll pop you in there. We'll get rid of you there because you're not anything anymore. This isn't, it's not that anymore. So this comes out here. It comes into here. And mute string it's saying. So let's make that a string. Colon, colon, new. Alright, and we do need it mutable. There. Right, what are you after? Blah 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 blah, fail string. Okay, so you're an and sign. Found reference and string. Okay. If I take that mutable off there, yeah, it automatically goes straight. Yeah, okay, so it's got a match. That's interesting. That's not how I expected it to work. That's a buffer. Load the item into the buffer. Just because it's a string doesn't really matter. What's it actually going to load? There's the question. The new lines are included. I'm just going to print it out and find out. This is a debug. Please remove code. And debug. That's how I note it all, so do apologise. We'll pling that one. And we're just going to just going to do that and that. What can we put in here? Number items, and I'm going to just throw in current file. Data current. Yeah. I wonder if that'll work. Oh, that's going to cause problems. Okay, so data files, and we're just going to load it. Okay, how we're looking. So that's just a quick and simple loading of data files. Create a buffer, load an item into it from item from. Yeah, okay. You see, it was easier to write the second one than it was the first one. But is it right? We're going to get a big printout, aren't we? I don't think it is right. Okay, it's gathered data. Directory exists. Help. Try simplifying it as shown. Pling directory exists. Can be replaced. Yeah, I know it can. I see. Yeah, but is that more readable? One dead code, that's fine. Interesting. So what it's complaining about is this. What it's saying is we don't really need to write that. We can not directory exists. Yeah, I can see that, yeah. Yeah. Alright. That removes that one. Okay. Let's just run it, and we should have something horrible happen. Interesting output. From file. That's very interesting output. Data written to file data config. Yeah. Let's have a look at our config. That's correct. Loaded data 0 test. Then it puts 4 more tests. And then it prints out loaded data 1, 2, 3, 4. Does anybody know why? It's done what we've told it to do. But it hasn't done it in the right order. Was anybody expecting this language to do what it's just done? That tells me there's 2 threads. On the print macro. The print macro is going, or print line macro is going into 2 threads. One thread is on the load data. The other one is printing out the while loop variable. Now loading data is usually blocking, so it loads all the data first. And then it prints out the rest of the stuff afterwards. Huh. That's buffered input. It's buffered our input. It's already done what I was going to do next. But it's working. Does this cause a problem? Possibly. We have to load this into a vector. No buffering either, since you're not using buffery. Are you sure about that with that macro? And I found out that buffer read and buffer write seem to be aimed towards TCP, which is well, more aligned with TCP. You can use it with files. From the research we did with the standard library earlier. That is very, very interesting. That is a good debug. That is a very good debug. Read to string. We're not using buffered, you're right. The string is the buffer. Okay. Result is a use size. Oh, right, the number of bytes read, or number of things read. Okay. If I go to the check this item of data, it's all going to work okay. But not necessarily in the order that I think it's going to happen. I think that tells me something. This is why we have to be careful. This is exactly why we have to be careful. Things aren't going to happen in the order that we, as humans, expect things to happen. We're expecting things to happen one at a time. That's not quite what's going to happen. The data from disk is going to be read in faster, probably, than we can fill up a structure for the data. As everything is in tandem. I can understand why they use the SERDI crate now, because the SERDI crate handles things in tandem quite happily, I believe. Wondered why it did. Yeah, I did have a quick look at it. Yeah. Can we straighten that out? Do we need to? So we reflected we tried to reflect what we did here. It doesn't quite work that way. This code works, but not as expected. That gives us a lot to think about. That gives me a hell of a lot to think about. I wasn't expecting that to happen. If it was writing in a language like Go, yeah, I'd expect that to happen. Didn't expect it to happen in Rust. Can you see me problem? I'm not sure until this line here what's happened to memory, where the data is. Is the data in memory? I think the data goes to our buffer. Yeah, the data goes to our buffer, but our print isn't working. Our print macro is being delayed somewhat. We need to know what's happening here. What is the state of our memory at this point? It looks like the state of our memory is that the data current is actually read properly. It's this print line that's the problem. It's as if the while loop is splitting in two. Just going to run a separate test on that. It's to do with the macro system. It's as if the macro is running in its own thread. Okay. I'll accept that. I don't mind that. For now, I need to think about that, because at the end of the day, if I start doing this check here to serialize, this could finish way after this data current. But we won't be using print line macro. Okay, I think we'll have to put a check in here. This is an interesting output. Raises a few questions. Okay, let's do that then. So base, save, and load data testing complete. Okay, we've got a completed initial testing phase of the commands that we can use or possibly use in the future, might have to alter some of these commands. Okay, I'm going to leave that error in. Well, not error, but thing. But that's given us something to think about. That's interesting. Okay. Like I said when I started this, it's not obvious what's happening, and this is the kind of testing that I do to try and discover how the code should be developed for the future. What pitfalls we can come across, what kind of things are going to hurt our application, and what can go wrong. And we've already found something that, to be quite honest with you, could go wrong. So let's do that. Let's do this. So we've now completed basic basic function tests. How can we put the results? Results. Unexpected. They're not as expected. And I think that's the key thing to take away from this. Is the code correct? Well, according to Rust, yes. Could this code be used? I wouldn't. This is a development environment, and this is why I use development environments. Can it be coded differently to give a different result? I think it can. But we've got quite a bit of code now to dig into and work out how it's all going to happen. I think I'm going to take probably a relaxation session just on this code, which means digging into it, finding out what the hell it's doing, because that is interesting. That is very, very interesting. I think we can use the save data okay, but this load data, that is a bit worrying. And interesting, to say the least. The other option is just to carry on and see if we can dig into that. It might be this read to string thing. Read all bytes until EOF in the source, appending them to buff. It's reading the whole file in. There you go. It reads the whole file in. on the first pass. The loop isn't required. It's not reading it line by line. We found the answer. It isn't 2 threads. You see what I mean? We need to delve into it to understand it properly. So it reads the whole file on the first pass. There's nothing to read on the second pass. It's already closed the file. It's ignoring this statement. It should give an error. Why doesn't it give an error? Huh? So it isn't check this item of data. This would be parse. Parse data and find the data that we need to see. Oh my god, that's got parsing in it. Okay. It's done that, read to end. Okay. There's no read line there. Huh. But we know what it's doing now. There we go. Okay. As the whole file is read at once. Which is the explanation that I like. That makes sense. Okay. And that's what we need to work on. I think that's good enough for a single day's experimentation, especially on something as complex as data files, especially when reading and writing, getting unexpected results, working out what they truly mean, always complicated. And whether or not we could do this differently. Can we not just read in a single line and then check it? Can we not do a while loop like this? I'm going to need to think on that. There's a little bit of investigation needed here. So let's like it, and I think that's the basics of saving and loading data. This check the data directory works perfectly well. That code's okay. It can be improved on. So we've got a to do there. I'll put it here. We'll just put improve this code. Yeah. Right, I think that's it. So thank you very much for popping by. It's been a great time. I do have to go now. I've just got a visitor. So take care. Get out there, have some fun. Probably see you Sunday.